Here's a demo of my RetroCalc app for Android Wear running on the square display of the Asus ZenWatch. And it's an RPN calculator, so if you haven't used that before, the way it works is you push numbers to the stack, let's say 2 and 3, so now you can see what the stack has, tapping the screen, 3 and 2 on the stack, and then apply operators to that, like multiply them together. Now the beauty of RPN is that you can work more complicated expressions from the inside out without having to maintain state in memory or write numbers down and things like that. So let's say we're going to do 2 times 3 plus 4 times 5. Well, then you can just continue 4, 5. And we have 3 numbers on the stack, the multiplication of 2 and 3, and then the 4 and the 5. Multiply. And we've got the results of the 2 inner expressions. Add that. And so that's kind of how it works. It's a scientific calculator, so it has, obviously it does regular arithmetic, and then with the function keys, the F and G keys, you can get all these other functions for doing, y to the x and the x to the root of y, e to the x, log base e, 10 to the x and log base 10, 1 over x, convert things to integers, generate random numbers and absolute value. You can do trig functions and arc sine, arc cosine, arc tangent. You do usually use the stack, but I do have a store and recall also. We've got e and pi there, useful constants. And then some stack manipulation things like swapping, rotating the stack up and down. One that's not on normal RPN calculators is over. That's a word from fourth. I find it useful to have on the calculator. The way it works is, let's say you put a couple numbers on the stack. Now I can lift this 2 to the top while maintaining a copy of it below by saying over. So now I've got 2, 3, 2. It took that 2 and popped it to the top of the stack without removing it. Let's see. One of the most interesting features is that since it's RPN, a lot of the time you can just put arguments on the stack and then execute a bunch of operations against them, and that kind of represents a formula of some sort. Like let's say we want to calculate the area of a circle with, say, a radius of 7.2. So you put 7.2 on the stack. Now, before I do the operations, I'm going to press record that into, let's say, A for area. You have 4 of these macro keys. Now what I'm going to do is square that, so y to the x, and then multiply by pi times. And that's the result, that's the area. Now I can stop that recording. And the beauty is that I now have this macro that if you put that value on the stack again and just play back macro A, you get your result. Or you can play it back against other values, say radius of 42. And you get that result. You could do unit conversions and various things like that and just program them and put them underneath the macro keys. That's kind of useful. So it was really easy to implement. It's just spend a couple of days over a weekend building this thing. One of the kind of tricky things that I got into was the representation of numbers that don't fit on the screen, because this is just a 7-digit display. So for example, let's say I put, what was that, 1 million, and I want to multiply that by 10. That's not going to fit on the screen, but automatically it'll switch to scientific notation. By the same token, if I put some very tiny number, and let's say actually I go to make that negative, and that won't fit on the screen with a negative sign, so it'll automatically switch to scientific notation. In fact, it switches back and forth as you do that. So you can represent very tiny numbers and very large numbers. There is no EEX key like you have on some calculators that support scientific notation, but instead you just literally do the operation. Let's say you want Avogadro's number 6.022141 times 10 to the 23rd power. And so what you do is you just put that on the stack and then just literally say 23 10 to the, and then multiply. And there you go, there's Avogadro's number. Now we've lost some precision on the screen. Internally everything is actually doubles, and so you have a lot more precision than is shown on the screen. So that's a little tour of the calculator. It's pretty cool. It's pretty fun to just have this on my wrist.